Great. Okay. Thanks a lot for joining back in. So let's take a look. So here's our problem statement, phase 2, making the market. And let's just start her off from the top. Make 100,000 buyers. Okay. Most likely in your first problem, you made one buyer. So probably going to have to make 100,000 buyers. And probably you're going to want them to do exactly what you did here, where you're going to have them purchase between 5 and 25 stocks. So, and make them participate in one market. So probably the first step is going to be to do something like this. We're going to say, okay, so that's 10,000 or that's 100,000, and make 100,000 buyers. And build portfolios for each of those buyers. So that might be a fun place to start to get things started. And this is your main. So you have your market, and maybe you print the market, maybe you don't. If you find printing it is helpful, that's great. You don't need to print it later on. So that might be helpful. And so you want to make them participate in one market where you offer each stock as an IPO or initial public offering. You guys are already doing that to a certain extent. So every time you make a stock, that stock has an IPO quantity. And that's just the initial amount of stock that gets offered. So when a stock enters the market, a buyer can buy it into their portfolio. Hence, you have build your random portfolio. So let's go on in there and look at that implementation. And build random portfolio. You're taking like for all your transactions, you're making stock purchases. So that's fine, and you probably already have that. So the truth of it is if you haven't finished phase 1 yet, don't worry, keep working on it. You're going to be awarded for it if you finish it in phase 2. So here's what I found in the past. Some of my students who struggle, or maybe they didn't get a great grade on the first phase, I found that some folks get a 0 on the first one, or maybe they get above a 0, but then they jump up pretty dramatically once they learn to code a little bit. So I had a student who went from 0 to the 70s. Then by the end, the student was getting a 92 on their programming. Now, if you're coming out of this class with a 92, that means that you should maybe think about doing this. Does that make sense? Like you really have, you have good training and you're going to do fine. If you're getting 92s on programming experience, that's really good. And you should disregard the 0s and you should disregard the 70s, because if you're consistently getting 92s, that's really good. It may take a little bit of time before you're getting the 92s. Does that make sense? It's a brand new culture. Some folks grow up with maybe a parent's a programmer. Maybe they have a certain amount of programming materials at home, and maybe they get some exposure. So the folks who had some exposure going in, they're at an advantage. And the folks who are doing it for the first time, I like those folks even better. Does that make sense? Like we wouldn't be making these YouTubes if we weren't fundamentally interested in first-time CS and first-time programmers. It's a far bigger victory for us here to have new programmers get success than it is to have the kids who grew up with awesome stuff acing everything. Does that make sense? So we are really on the side of the newbie in a big way. So let me say this. You may have done a lot of the stuff here, and if you're doing it for the first time here in the phase 2, that's great. So for example, each stock is an IPO. You probably did that. You probably already have that done. There's a price index storing the prices of all stocks. You probably already have that done. The index also stores the specifics on the stock, for example, by its industry. You probably already have that done. There's a likelihood you already have that. When a buyer buys, the stock price goes up slightly. Well, that's something new. So for example, and I was just kind of tapping away at this, I'm not finished. Let's say you build your random portfolio and you make a transaction, and then you add the transaction to your portfolio, and then you actually calculate a random number, which is a next double, and then you add that random price increment to the price of that existing stock. Well, what you're doing in that case is you're saying, well, every time somebody buys, the stock price goes up a little bit. Now, what I wouldn't mind doing, and here you have the market, what I wouldn't mind doing is working on that a little bit so that we're actually pointing back to the price of that stock back in the main market. So we'll be looking at that too. So once a buyer makes his or her portfolio, sell off stocks which have gone up in value. So that's pretty interesting. So that kind of contributes to the stock price going up. Once a buyer makes his or her portfolio, sell off stocks which have gone up in value. And so if you look a little further, there exists a list of holdings for sale. And these are stock bundles which were once purchased by a buyer but are now up for sale. So when you think about that, probably if you look at your market and you want to focus on your market a little bit more in this problem, you want to go back to your market and you say, well, probably I've got this array list of stock, but probably you also have an array list of transactions. And that's what's called a for sale market. Now, if you thought that the stock index, the M, or the price index, was big, and in fact, it is pretty big. You have 6,000 stocks. If you thought that was big, probably your for sale market is going to be many orders of magnitude larger, because you're going to say, well, every time somebody finishes up, populating their portfolio, they're actually going to sell stuff. So probably you want to think about, I was creating a method here called search for saleable holdings. And what we're going to do here, and I hadn't constructed that yet, I said, why don't you go ahead and create a method, search for saleable holdings. And we can just delete that, that's fine. And then why don't we put a little documentation here where what we're going to do is take the existing portfolio, loop through it, check the price of the holding against the current price of the stock in the market. And then if the price of the holding is less than the current market price, you've made money, and sell it or put it up for sale. So this whole notion of putting something up for sale means that there needs to be an array list in the market that can hold transactions that people have made before and that they want to have it up for sale. So what I did is I went into market and I made this array list called a for sale market. So we're doing a little bit of, just kind of putting things in place here. So we're going to search for saleable holdings. And this rule set is going to take place there. So we're just doing the initial work here. And so that's going to be the holdings for sale index. And once a stock sells out of its IPO and a buyer wishes to buy it, he or she must buy that stock from the for sale market. So those are going to be some important things to take advantage of in phase 2. So that kind of goes back where we're going to say, when you build your random portfolio, you should be able to check for the stock in the market, and if its IPO quantity is equal to 0, shows the for sale market for stuff that's also on sale. And so that's going to be a new rule. That's going to be a new rule that's going to be present within our system. And it's going to relate to this for sale market. And so I'm going to let people think about that a little bit. And that's going to be the end of phase 2. And now we'll move on to phase 3, when we get there. So I just wanted to sketch out those little pieces that, now if you're thinking about it, really, at the core of programming is the collection, the array list. And for students of this class, you guys are taking the array list for granted. We're not we're just putting it out there. We're just like birds and the bees. Here's how it works. Simple A, B, C, D, E, F, G, 1, 2, 3, 4. 1 plus 1 is 2. Array lists are just places where you store object types. Now, you guys have made a transaction. You guys have engineered the transaction class. So here's the transaction. A transaction is just a record of something being sold before. Now, if you're thinking about if a buyer has a portfolio, which is an array list of transactions, that's pretty cool. So, any given buyer can have a kind of a list of stuff that they've bought, but probably you want to include the name. If you're going to put one of your transactions up for sale and you want to make money on it, that's fine. But probably inside of your transaction, you probably want to have a string which is called the buyer name. And you want to say, record the buyer's name in the transaction for when they put it up for sale. Does that make sense? So that way, when people buy that transaction, you're holding, the money flows back into your budget. And you can debit, or rather credit, the budget once you've sold something. Does that make sense? Now, here's the deal. You guys are programmers, and let's just say this. The amount of knowledge related to programming language is limited. So right now, you know a vast amount of Java. And let me say this. Programming languages are all very similar in that they're limited to variables, if-then, for loops, maybe some while loops. For loops are really the crux of it. Arrays and array lists, i.e. collections, functions, and objects. And that's it. That's all a programming language can do. And the reason why I say that is that my teacher, it was a wonderful teacher, and he was a Yale PhD. He actually said this to us right about at this time when I took intro programming with him. And I realized that that was a very important moment. Now, he was an expert, he was a PhD, so he had invented various programming languages. So for somebody who invented languages to say that to me was very influential. So I always try to pass on that message right about now, where you guys may be saying, well, programming is so complex, it's such a brain buster. Really what I'm saying is it's kind of like working with bricks and cement, where the skill set is finite, but the what you can make with bricks and cement is pretty infinite. Like you guys can make some pretty big things, and so you're thinking, well, is it hard to use bricks and cement? Well, there's a real skill in doing that. It's a skilled trade. Programming is just a skilled trade. But if you think about the architectures that you can make, that's where it becomes the sport of a very educated, very erudite group of people, because they're really thinking about the strategy of how do I get to where I want to get using basically blue-collar workman style skills. That's where you guys are at right now, which is a wonderful place to be. It's really a great place to be. So programming languages, finite knowledge, finite understanding. What I just said. It's very easy to master programming languages. In terms of what you make, in terms of software products, the challenge is not bounded. This program could be infinitely interesting. It will always come down to your strategy about how you want to implement it. But let's say this. Whenever you want to try to solve a problem, it's always going to come back to your uses of array lists. Array lists, add, delete, get. For loops, which are either going to be regular or enhanced, right? The regular look like this. Here's a regular for loop. And also it's going to come down to, here's another regular. And then it'll come down to some functions and some classes. And that's about it. So in many ways, try to keep your solution very simplistic, but take the time to design. Take the time to draw some pictures and to say, well, if I wanted to create, like for example, if I wanted to create this holdings for sale, probably I need to begin with an array list. And then probably I need to kind of push things onto that holdings for sale when I'm sort of done with, my my portfolio, when I'm done building my portfolio. So the question here is, it'll come down to, well, if I do everything inside of main, main can see everything. As long as it's, we try to make as many things public as we can, and because of that, look at all these public variables, and we try to make a lot of things public. And this name can be, private. I think it could be, for our purposes here, all this stuff can be public. But the main can see it all. So maybe what you do is you go b.search. I believe that, and here's another trick just in case you got a big, let's go into the buyer, and you can take a look at all the functions inside of here. Search for saleable holdings. Oh, it's private, so let's just make that public. Think about what you can do here inside of main. You say search for saleable holdings. And then maybe search for saleable holdings yields some other kind of result. Like for example, search for saleable holdings. That's fine that it's void, but what if it returned an array list of type transaction? What if that returned that? And then most likely it wants a return statement, add a return statement. And we'll finalize that. But what if in your design you said, well, why don't we make an array list transactions called T, which is a new array list of transactions. And then what if you could say that T is equal to, the results of search for saleable holdings. And just in case I made an error here, oh, transactions. Well, we only have transaction. Sorry about that. So what if you had something along these lines? And what if your saleable holdings should be put upon the for sale market? Maybe you should say T is going to be built here, and that's going to be the stuff for sale. We're just doing a quick exercise here just to get you started. Doing a little quick hacking just to think about it. And you don't need to be fast. Just write just do something you should always do something to change the way you think. Does that make sense? Don't think about something to change the way you act. Act to change the way you think. So lay a few lines down to think about it. And then we'll say, what about if the market, your market, what about for all that you go market dot for sale market dot add. What if you could add all the stuff within the T? And you could say for every transaction, inside of T, what if you could kind of add all the stuff that's inside of that? That might be a fun way of kind of pushing stuff into the for sale market. Now, what's going to be interesting is this is going to kind of balance itself out. And sorry, I'm going to put that right here. It's going to balance out as new buyers are added to the marketplace. Because we're also going to say that the buyer is also going to say, well, as she or he enters, this build random portfolio is still going to be a cool place. It wants to check if the stock is IPO quantity 0. And if it is, then check the for sale market. So I'm just going to leave it right there, and I'm going to pick it up in a next lecture where we'll take this to the next level. But I want you to consider what small pieces of code can you add, soon that can change your position. But here's what I also want you to say. Spend more time analyzing the product than you do coding. Coding is dangerous. Coding could bring you down some dangerous part with. Be conservative as to what you put down in the compiler. Programming is not in itself a solution. The solution will pre-exist the programming. Does that make sense? You will always program to fit a pre-configured solution. Spend more time with your friends talking about a pre-configured solution. And then once you feel like the solution is kind of there in front of you, then start to write some really obvious lines down. Understand that programming is a workmanlike process. Your real genius is in your conceptualization, in your ability to work through a solution like a geometric proof. And to say, because my theory seems valid, I'm ready to lay down some code. When you think about the idea's pre-existing solution, that is a definition for architecture. An architecture is a theory that something could work. And let's try something out. I feel good about this. But right now, your problem is not the programming. This is not your challenge. You're probably good at this. This is conceiving of the requirements here. That takes some time to absorb that. So I don't want you to see coding as your solution. I want you to see your grasp of the requirements as a solution. And you need to work beyond this lecture. You need to work on your own personal time. A programming class should take 12 hours a week. That's what a programming class needs to take. It takes more time. It takes more time than many other majors. Okay.